All right. So we're going to talk about did product management or product management for decentralized identity. So my name is Wade Chang, and I'm the co-founder and CEO of Spruce Systems. We work a lot on decentralized identity as a company, and I'm here to share with you some of our learnings. I'm not going to go over some of the basic product management stuff. I think there's like a lot of interesting ways to define product management in the first place, but I think a lot of people can agree that they're based around user stories, defining use cases, working with engineering teams, and figuring out what's an excellent experience for the end user, what's going to see market adoption, right? And as CEO of the company, I'm responsible for a lot of the product management to make sure everything's moving forward. So I hope to share with you some of the specific points around building decentralized identity software that you might find helpful as you begin your journey or continue. So our agenda today is to talk about the goal of decentralized identity, key insights into it, the hardest problems for end users, things like why put stuff on the blockchain at all, who needs standards, when can they. Okay, wonderful. Yeah, I think muting happened. Thank you, Michael. All right, so we're gonna move through this pretty quickly because of time constraints, but who needs standards, Spruce's approach, signing with Ethereum and beyond. So the main goal that you might have heard from a lot of the other speakers is to move from a world where the user is gated access to a platform, and after they log into the platform, maybe they can access some of their data again, to a world where the user can just carry their own data with them, right? In their identity wallet, in a database they control, and they basically make the apps authenticate to access their stuff instead, right? Kind of really flipping the script. And we think this is great from a self-sovereign identity perspective, because that is many of the goals of self-sovereign identity, as you heard Doc Searles talk about and many other speakers. Also, it's great from a privacy and a bunch of other perspectives. So the real nuts and bolts of how all solutions are going to get there are to basically produce these granular data controls that are easy to use. What this boils down to is so-called zero trust architecture for individuals and organizations, not assuming anything at face value or any kind of secured perimeter, but just being able to permission each individual request. So when you're sharing your photos with the website, right, you know exactly which photos the website gets to see. And we're getting rid of this really coarse-grained, there are a bunch of things you don't even know what you're sharing to them. We're getting rid of that and letting you be a lot more specific about what you're sharing. A lot of this zero trust architecture is enabled by decentralized public key infrastructure, meaning that as we move to key-based cryptography, you'll see that a lot of the protocols that the speakers talked about in this conference rely on public key infrastructure. Sorry, that should be DPKI, not DKPI. So, and to make these systems usable, we really need trust in user experience, meaning that the user needs to be able to feel confident the software is going to do what they expect it to do, and it needs to be easy for them to do it. So towards making it easy for users to use this software, these are some really important facts that we learned over the past 4 years or so. I should give a little background on myself. So my name's Wayne Chang, and I've been working on this problem for a number of years. Spruce is like a year and a half old, but before that I was working at Consensus, which is focused on the Ethereum blockchain. And I was running the Department of Decentralized Identity with a few other directors, and we talked to a bunch of users there. Before that, I come from a security and startups background. So one really important thing we learned over those years is that users don't trust new brands with their most critical data. So if you're like a startup like Spruce or some other companies, I don't think that you've earned the privilege yet to tell users to move everything to you, right? They trust brands they know about, brands like Apple, brands like MetaMask, brands like Android. And users can't be expected to be experts at key management, broadly speaking. You can't just think that users can have these keys and show up with their keys, because there's a lot of steps before that's actually possible, right? Also, standards and specifications don't guarantee that you're going to have a winning product. Because you check a lot of boxes, that's great, and that's probably pretty relevant for government work. But at the end of the day, if you're cool, so let's continue to talk about this. So some demographics are easier to approach than others, and we'll tell you about the ones that Spruce approaches later in the presentation. But even if you just start thinking about it, someone who has their keys to begin with, that's a lot easier of a problem to solve if we need keys for everything that we do, right? And some people are just more adept at technology. Some people, their view of the internet is just going on Facebook and they don't do much past that, right? But at the end of the day, for all this stuff to work, it's all about adoption and network effects. So what are the hardest problems for end users so we can make it easier for them, right? Well, for them, it's being able to understand digital interaction workflows. So people might be experienced with like signing something like a document in real life. And you'll see things like DocuSign try to get as close as possible to this experience, right? But there's just a whole new class of things that are possible digitally that we don't have a great physical analog for. So we have to think about how to convey those experiences to the user, right? So when you authorize someone to access your data vault, for example, how do you do that? What should that look like? That workflow doesn't exist today in the industry en masse, right? So we have to think about parallels from the physical world about, okay, it's kind of like giving someone, a hall pass or a permission slip, right? Other problems that are really difficult to solve and really benefit end users is preventing identifier and data correlation. If they use their same decentralized identifier everywhere, then there can be third parties causing a privacy problem that are able to collect their visitation habits and things like that. And finally, the biggest baggage problem of them all that we've seen some pretty great strides over the past 5 to 10 years is key management. Managing keys is a hard problem. No single company is going to be able to solve this. This is going to be something that we're going to have to collaborate with on as an industry and solve through standardization and best practices forward. This is really tough. We work a lot in the world of Web3, and we see all of these problems getting better through the following ways in Web3. So being able to understand digital interaction workflows, Wallet UX is really the key here. And you'll find that Wallet UX is the solution for many of these problems. You'll find that the mainstream wallets out there, if you're looking at browser extensions, that's MetaMask. If you look at, and Phantom, if you're on Solana, for example, if you're looking at mobile solutions, you might check out Rainbow. You might check out Argent and a few others. And these wallets are actually doing a great job explaining to the user what they're signing in the world of blockchains. When they're basically sending assets around, right, then you'll actually see a dialogue that's like, this user is sending, you're about to send this amount of money around. This is the approximate worth in USD, right? So the signing operation is actually made very intuitive for that particular use case. And as we move into identity use cases, we need to rely on the wallet UX to do more to make it easier for the user. Preventing identifier and data correlation, again, that's wallet UX. It's closely tied with key management here, right? Because if you can manage, unlimited keys, and you can have a key for every interaction and figure out how to link the right keys, then you're able to prevent identifier and data correlation. Zero knowledge proofs are another way that we're evolving to approach this problem. Basically, how do we prove things without giving away information? I think the really canonical example people use is, how do you demonstrate you're over 21 to buy alcohol in the United States, for example, without actually revealing your date of birth, but convincing the verifier, right, that you are. So that's important. Key management is being improved by Wallet UX, as I said, introducing a bunch of things. For example, the Argent wallet in the Ethereum ecosystem uses smart contract wallets, as does the Gnosis Safe. And that uses EIP 1271. So the smart contract is actually used to gate signing. And within a smart contract, you can have a multi-sig scheme where you can swap out keys, right? So you can do 2 of 3 or 3 of 5. And if any of those keys are lost, you can replace them. This allows for threshold signatures and social recovery schemes. So a lot of these hard problems for the user experience are being tackled in Web3. And if you're not in the Web3 ecosystem trying to employ these self-sovereign identity technologies, you can look at a lot of the progress here and try to map it to your own use case. Another thing that comes up a lot, especially when you're thinking about decentralized identity products, is like, where does the blockchain come into this? I think that there are 2 ways. One, you can solve problems for the blockchain, like helping DAOs credential their users or being able to provide creator authenticity for NFTs. We do this at Spruce. And you can also use the blockchain as part of like a module within your product, right? So specifically putting stuff on the blockchain, everyone knows it's like a horrible idea to put stuff like medical records and other sensitive data in what is presumably going to be public and immutable forever and always, right? So there are some use cases though for your subcomponents that could make sense to consider a public blockchain for. And we're team public blockchain here at Spruce. We think that private blockchains are basically pretty limited utility. You might as well use a database for a lot of those situations, but we can talk about that later if anyone wants to. So use cases are like storing documents and service discovery. This is effectively, replacing DNS in some sense. And you're able to, if you trust like the Ethereum blockchain and not IANA, right, you're able to use Ethereum instead of DNS for some use cases. And DNS isn't necessarily meant to store a bunch of like service endpoints and things for DIDs, right? Whereas a general purpose computing infrastructure like Ethereum, or even a less general purpose computing infrastructure like Bitcoin, you can store some stuff in there if you just pay the price, right? And that's one of the things. It is expensive, but there are layer 2s that make it a lot cheaper. We see a lot of identity plays in Web3 crop up on the Polygon blockchain, by the way, which is seen as a layer 2 to Ethereum. It runs on the EVM. It's very, very cheap per transaction. And it is anchored to the L1. Revocation's not a horrible idea to store on the blockchain either, but if you're doing revocation in the blockchain, you might consider something like a cryptographic accumulator, which can help you achieve a privacy-preserving outcome. Credential schemas that everyone can see, that's fine. In fact, like, the whole reason to have a credential schema that's public is so a lot of people can interoperate, right? There are also various things like trust lists, public credentials, that could be a decent idea to store on the blockchain if you're okay with the level of visibility and the privacy policy. So they really bring the benefit of censorship resistance and strong network effects. I think strong network effects is far more interesting. So if you're able to, collect NFTs over a bunch of different projects, then all those projects kind of interoperate with each other, right? Because they're built on the same standard. The sacrifice you're making is, everyone can see that activity because it's on a public blockchain. So I think that eventually some combination of NFTs and verifiable credentials could be how a public identity is assembled, and with private elements as well. If you squint, NFTs and verifiable credentials are actually very similar. I think that, some people are calling it a non-transferable NFT that is tied to an Ethereum account, for example, and it might represent something about the account. VC's verifiable credentials also represent something about accounts when the Ethereum account is the data subject, right? So there are different confidentiality settings, of course, namely NFTs by default are, forever public, and you might hide them in a ZK rollup, for example, and you get a little closer to a verifiable credential, or you might publish a verifiable credential on chain, or a reduced appropriate subset of it published on chain for use within a smart contract. So they seem like different points on sort of a lot of the same spectrums. That's how we kind of view them. It just depends on how do you want to achieve privacy for the user, and you have to think about what definition of privacy you want to use. We like the definition of privacy that it's being able to exert appropriate controls over your information, right? And if you really want to make something public for people and you understand what you're doing, this gets back to the UX and letting the user understand the digital interaction, then actually we don't feel strongly about stopping the user unless there's some kind of, underlying effect that in aggregate would be disastrous, right? So it takes a lot of thought and it's definitely a new space. Other things is user-controlled authorization via key pairs. You can use like NFTs and asset ownership to gate access to different things, which is very interesting. And some examples of blockchain-like networks, probably people here are familiar with them. Ethereum or EVM compatible is like Ethereum, Mainnet, Avalanche, Solana, Clayton, etc. Some Cosmos chains like Terra and Osmosis. And also things that kind of look like blockchains, but aren't, really, like Ion and Element, which are based on CRDT updates for DID documents, right? And Microsoft is really, investing resources into Ion. We're seeing Element also similar, but rooted on Ethereum. Cool. Some other thoughts about waging standards wars. So if you're, in this room, you probably talk about a lot of different standards, and I just wanted to share how we approach it as a startup. So there are a bunch of tech standards orgs, and throughout history, they've done an awesome job standardizing stuff, creating common goods that everyone's been building on, right? Without W3C, I wouldn't be able to talk to you right now because there's probably some kind of, HTML component to what we're talking about, or CSS and everything. Without the IETF, we wouldn't have the video codecs and everything. So just monumental, important, great outcomes, right? But when you're working in a growing and adopting market, and the market hasn't fully determined like all the winners yet in terms of standards wars, then basically you have to consider really carefully about what you're going to build on, right? This is really important for a product manager who has to make recommendations based on, business objectives and limited resources. So standards are based on network effects, and de facto standards exist. Even if, it's not at a formal, group like these where someone proposes something, what happens a lot in the industry is that 3 or 4 large players will just decide to do something some way and try to standardize it at one of these industries, right? And basically, if they already have the volume and the traffic, then and the network effects, therefore, that's a lot of leverage to be able to set a standard. Right? Because like, why should they change if they're already doing it and they're getting all the traffic already? Why should they have to think about other things? This is where it gets very political, and you have to, again, just think very carefully. But some high-level economics for standards. And I think there was a really good piece by, what's his name? I think Halvarian, Waging Standards Wars. Carl Shapiro and Halvarian wrote a book called Network Rules, I think, and they talk about, waging standards wars. One of their big takeaways from the economic side of it is that it provides benefits for entrant firms and weakens incumbents. What that means is that if you're already implementing a product, right, and all of a sudden there's a standard and you're kind of the market incumbent, then it's a lot easier for new firms to come in, just check all the boxes off for the standard, and the market's there already. They can start competing at that level and differentiating in their own way, right? So standardization reduces the amount of lock-in that one incumbent can have. So I think this is why a lot of governments tend to like the direction of standards to prevent lock-in to like IT vendors and things like that. But in decentralized identity, the space is moving really quickly. It doesn't guarantee success that you comply with a certain standard if no one cares about, buying products or using stuff that uses that standard, right? Sometimes you might be very proud of, oh, we implement this workflow or that workflow. And then you have to ask yourself, well, how many users or how many businesses actually like have this already, right? And it's a big chicken and egg problem. Again, back to network effects. So one of the things that seems to be consistent, though, is that if you require anyone to just buy into your new standards ecosystem to see value entirely, unless you are like Microsoft or someone huge and you can just foot the bill for them if everything goes wrong, so they win either way, you're asking them for a really big thing and you're probably going to lose. So worse is better, I think, is the right mantra. It's an amazing essay by Richard Gabriel. I read it once every while, but it's also called New Jersey style because I think it's talking about how Unix, which was invented, in New Jersey, and basically talks about how that worse approach, Unix would like break down all the time in the early days, actually gained a lot more traction than the Lisp machines, which were made to be correct and theoretically optimum, but they just had huge problems getting market traction, right? And if standards are based on market effect, well, Unix became the de facto standard. People gripe about POSIX, but Unix systems are everywhere and people know how to use them, right? So I'm going to talk a little bit about Spruce's approach towards all this. And I will slow down a little bit to help our interpreter out. I'm very sorry, Beta. So our approach is basically looking at the Web3 ecosystem, being inside the Web3 ecosystem, and really interpreting that as Web3 users already have key pairs. MetaMask is just one wallet in the Ethereum ecosystem, and Ethereum is one blockchain in the blockchain ecosystem. There are like 21 plus million active monthly users, right? And where else do you find so many users with so many keys using them in serious ways? If you look anywhere else for some kind of decentralized PKI effort, I would argue it's several orders of magnitude less, unless you talk about government mandated efforts, such as Estonia, where everyone has, a key pair within their e-citizenship card, right? And there are some other teams like that, but those are kind of locked away to very proprietary protocols, probably for good reason. So, and if you think about which demographic is easier to work with and more experimental and wants more control over their data, Web3 users is actually quite a good choice. So at Spruce, we focus mostly on Web3 as a result. And we see that blockchains are the singular most successful public key infrastructure event for individuals in history, right? So we go off of that. Key management is already being solved by multiple wallets that have, some of them have great social recovery techniques. Some of them are multi-sig smart contracts. Those are being solved at the wallet layer. And we're really excited to be able to just build off of that and not have to solve key recovery ourselves, because at a startup, you have limited resources and you need to really pick the battles that you want to work on. So today they are mainly used to sign blockchain transactions, trade stuff like NFTs and assets, etc. But why not use the keys for other stuff too, right? And that's basically our thesis. And the first thing we can start with is signing in with your keys, authentication, right? So we collaborated with the Ethereum Foundation and ENS on letting users use their Ethereum accounts to sign in to a website. Basically, you can sign in with Facebook, sign in with Google. Why not sign in with Ethereum? For folks who are familiar with the identity ecosystem, this is pretty similar to WebAuthn. There have been even talks about using PGP for authentication, but again, there are tens of millions of monthly active users ready to use their key pairs for other things. So we standardized a message format for how you would sign in with Ethereum, and it looks a lot like a JOT, a JWT. But a specific JOT for a purpose. So, we use things that have precedent in ITF, but at the same time, we innovate on being able to use it and go to the users where they are and make it good for them, secure for them, work with applications and browsers to ensure adoption. So we're really excited about sign in with Ethereum because we're getting a lot of interest, not just from Web3 companies, but also Web2 companies. Public magazines are interested. We're talking to sports associations that are interested. Basically, any Web2 company that is interested in having a Web3 strategy sees sign in with Ethereum as a great place to start, because they're able to see how to link their existing user base with on-chain activity if the users want to reveal it to them. And that's basically very attractive to them. We see it as a way to support a direct authentication method, which does not need an intermediary. So after users sign in with Ethereum and authenticate, what else can they do with their keys? Well, here are some things that we're looking at. So W3C as W3C decentralized identifiers and verifiable credentials. Of course, we do think that these are pretty great and interoperable, as you heard many other speakers talk about. We take a slightly different approach. We want to just talk to all Ethereum users, for example, and say, hey, you have an Ethereum address and a key pair. Great, you already have a DID. You don't have to like create a new DID because just like a DID key, DID PKH stands for public key hash. So that's what an Ethereum address is. That's what a Bitcoin address is. That's what a Solana address is. That's what any Cosmos chain address is. It's just a hash of a public key and some further mangling. So if we can just design a DID method that understands those as having a default verification method, then all of a sudden, we have millions of people who already use DIDs, and we can define how you would issue a verifiable credential from those. We've done that. And now you have MetaMask able to issue verifiable credentials, right? And we've seen great traction in terms of people actually wanting to use that. And other things that can happen are you can take your building blocks of DIDs, and I think you can compose them to other DID methods. So what if a DID PKH, an Ethereum address, could be the authentication method for a different DID, because DID PKH, like DID key, would not have key rotation. It would not have the ability to broadcast a service endpoint, right? So what if you wanted to just use that as the authentication method for a different DID method that did support those things? So that's a lot of what we're thinking about in terms of worse is better. How do we start with network effects and traction and just keep on growing it, right? Because every time you're building your own little kingdom that's no one's using, then you're having huge adoption risk, and that's the biggest thing that can kill the ecosystem. It's the biggest barrier to adoption. So it's important to look at where the network effects are and be able to use them. Another example, not in the blockchain world, is X509 infrastructure. Why rip and replace that if people are good at key management already, right? You just use the public key infrastructure that exists, figure out a DID method that's compatible, and then now everything's interoperable, whether it's X509 infrastructure set up by the federal government, or if it's DID PKH and it's a new Ethereum address built in the user's wallet. That's how we achieve self-sovereign identity that actually is pragmatic and is interoperable and works. Another interesting thing that's possible is blockchain hosted permissions. Imagine a user's smart contract can govern their cloud infrastructure. I'll show you in our product Kepler soon that that's exactly how we produce self-sovereign storage. We let the user control a smart contract. Well, we don't let them, they just control it because that's the nature of a smart contract. And they're able to specify a list of hosts to clone their data and nothing past that. You can also figure out access to user controlled storage with signing, right? So you can create these capability-based permission systems that act like hall passes to give different services access to pieces of a user's data vault. So this DID kit is one of the important toolkits in our approach. It's an open source Apache 2 cross-platform library, and it's written in the core at Rust. We chose Rust because it's efficient. You can run it in IoT environments. It has a really great type system for security. And also, we just took a bet on it pretty early, about 1.5 years ago, and it's playing out really well, I'd say. We compile it so that it works with other languages, including really enterprise and government-friendly languages like Python, Java, JavaScript, etc. DidKit will even compile to mobile platforms like iOS and Android. We have a Flutter application that demonstrates this called Credible. So what DidKit gives you is support for various blockchain accounts as DIDs and other key material, bunch of different DID methods. It's kind of DID method agnostic. And if you don't see your DID method here, you could just add it in as a module and it's fine. Or just ask us to write it and we'll see if there's enough demand, right? And we got all these DIDs working with major protocols that interoperate with verifiable credentials and authorization capabilities. That's a big part of what you get out of it. And also we're building in crypto agility. So if you're trying to deploy DidKit to like a phone that has a hardware P256 module, that's a specific elliptic curve that is NIST recommended, then all of a sudden you should be able to, at compile time, decide if you want to use the Rust implementation or the hardware call on the device, right? So that level of flexibility to allow different builders to pick which cryptographic backends they want is really important for us. You should be able to build DidKit eventually. If you don't like blockchains, that's fine. Just build it without any blockchain support and use PGP and X509 infrastructure if that's what you like. And if you just care about Ethereum, you can just build it with Ethereum support, right? So the point is, we're trying to produce a public good here that is going to reduce people's time to market for decentralized identity solutions. We'll be releasing a formal security audit by Trilobit soon. Really impressive security team, probably the best you could work with if you wanted to figure out something with Rust, cryptography, and blockchains. So go to spruceid.dev and check out the tutorial. Run the command line if you want to check out DidKit. If you want to incorporate into your own project, feel free to join our Discord. We provide lots of support. The other big thing we work on is Kepler, and we call it self-sovereign storage. And the idea is it's a user-controlled storage vault governed by a smart contract. The user controls a smart contract that specifies which hosts can hold its data and not pass there. So basically, if you have a few hosts in your Kepler orbit and you stop trusting one of them, well, maybe you add a different host, you make sure it's fully replicated, and then you eject the other host from your smart contract. Users should be able to use services for this, or they can self-host, whether it's running in their basement or in their personal cloud. We put a lot of effort into Kepler so that it can basically run pretty easily for the user. This is something that we're releasing Q2 this year. It's built on top of DidKit, so all the blockchains and DID methods and verifiable credentials that DidKit already supports, Kepler also supports. So you'd be able to share data across different DID methods, right? Anything that DidKit would support. Also, it works perfectly with signing with Ethereum. So people who sign in with Ethereum and then want to load private data as part of their interaction can do that, and they can refer to their Kepler data vaults for that. I want to talk about how we use capabilities. And this is, I think, important functionality that it's going to be a use pattern. I know this is product management, but let's assume it's technical product management because we're on the technical track. And we have an exploding permissioning problem with respect to data access, right? Like you might want to check that someone is authorized to access your data before they can do so, right? And it's kind of impossible to just think about a role-based access control system for all the roles in the world, right? Some contexts, you have auditors who are allowed to access log files. In other contexts, you have teachers who can access people's homework, right? So being able to just list out everything that exists, I think is pretty intractable of a problem. It's very difficult. So instead, we think that they should be very flexible and easy to understand and easy to use to define custom permissions. Capability models basically work like a hall pass. If you want to give someone privileges to do something, you might write their name in a hall pass and sign off on it, right? And it would be very similar in a digital world. So users can define new permissions with one of our research projects called cryptoscript and authorize with their keys. So cryptoscript is the solution to the infinite permutations of permissioning, because something that has infinite solutions is programs written in a programming language, assuming you can have arbitrary length. But we want to build a DSL called cryptoscript inspired by Bitcoin script that is non-Turing complete. So it's very easy to analyze automatically for security properties, easy to implement, and a whole bunch of other reasons. It's a weaker language than a full Turing complete language, right? And we want it to be highly extensible. So this is known as policy as code. And with this, you can create arbitrarily matching representations. We're not finalized on the syntax yet, and that we have early versions of the compiler. You can follow along our progress if you want to, but it's an interpreter right now, but eventually, we'll be able to compile the bytecode. If you want to define a subroutine that works across blockchains that says only a certain NFT owner can access a file, right? You might have someone countersign a capability to you. You might resolve an NFT that you're expecting, push the current owner's address onto the stack, see who's countersigning for the capability, put that address into the stack, and have an equality assertion. Then this subroutine can be reused anywhere to have this. You can also use cryptoscript to accept verifiable credentials within a verifiable presentation, ensuring the proper holder binding for the presentation and any other important factors. You can mix and match the two. You can even write a module for SAML too if you really wanted to. So this is some of the stuff that we're working on at Spruce. And one bonus one is TrailDR. One of the problems we encounter over and over again with respect to verifiable credential solutions is that data schema languages are really hard to use. Anyone here who has written like JSON schema, or if you're brave enough to venture down to JSON LD, knows this, right? So we want to make it really easy to use. So we're building something called TrailDR. TrailDR was picked as the name because of the semblance to the English abbreviation TLDR, which means too long didn't read. And that's the purpose. Like instead of 200 lines of JavaScript, or sorry, JSON for JSON schema, what if you could express something in just 20 lines of TrailDR? And also you can have semantic encodings for JSON LD, et cetera. So we're also working on a different kind of language parser for this. The magical part of TrailDR is that we're able to combine it with didkit, and you're able to specify something like a profile and produce an SDK in the target language because didkit is cross-platform. So imagine you can generate an application level SDK, and the application level programmer never has to think about what elliptic curve do I use, what verification method or proof suite, none of that. They just type, is this certificate verified? Is this profile signed off on? And that's it. And they can think purely in the business level. So this way, it's a lot easier for whoever's designing the schema to be careful about architecting all the correct cryptography and data schemas. And then the application programmer has a much easier time, including things like definitions for migrations that are upgradable or downgradable, and even how to publish the schema to a public source. Cool. So basically with Spruce, users will sign in with Ethereum to the key controlled revolution. That's a lot of our focus. I went through some of the cool goodies we have coming up. And if you want to learn more, go to our website, spruceid.com. We put a lot of updates on our blog, a lot of technical updates too. You can connect with me on LinkedIn. Wayne Builds is my LinkedIn moniker. And I'd prefer Twitter. So if you want to follow me at WYCDD, my DMs are open if you want to chat. It's probably the easiest way to get a conversation with me if you want to talk more about something. And that's kind of it. So I really thank you for listening to my presentation, and I think we're at time.